All right. All right, perfect. So yeah, let's start. Today, the 16th meetup from Flutter Belgium. Pretty nice. So yeah, I want to start with thanks for hosting Asia Group. Thanks for the food, thanks for the drinks, thanks for the nice office. Pretty cool. So maybe if you want to give a little explanation of what Asia Group does when they started, just a brief overview of everything they're doing. It would be nice. Yeah. Yes.
Hi everyone, I'm Jurgen. I'm what we call the pod lead of the mobile team, business unit manager, team lead, whatever you want to call it. For those of you who don't know who ACA is, we're an IT services company. We already exist for about 30 years, so quite a long time. Company of almost 300 people with offices here in Hasselt, in Antwerp, brand new office since a few weeks. In Ghent we have an office, and in Leuven. And we do all kinds of things in IT. We do Java and .NET backend. We do low code. We provide cloud hosting, data services, portals, e-commerce, and of course mobile. And so we have a mobile team of about 20 people purely working on mobile, with a focus on, let's say, roughly 50% React Native, and the other 50% is Flutter, of course. So that's why we're really happy that we can help Flutter Belgium in doing these meetups, because we really want to be an ambassador in Belgium and Flanders for Flutter. So enjoy.
Great. Thanks. All right. So maybe a little overview of who Flutter Belgium is, or what we're actually doing. So Chris started Flutter Belgium in 2016 or 17, I think. And Jens and I, we joined last year. And what we try to do is indeed, make sure that we share knowledge with other like-minded people who love mobile development, who love Flutter. Share a lot of different talks and make sure that we give a platform to people who want to come and say something. So you can join us on all different kinds of social media platforms. But yeah, of course, we're always looking for speakers and for hosts. I think host is going quite all right. Speaker is a little bit more difficult. But I think everybody has something to say that is interesting. It doesn't matter if you have a couple weeks, a couple months of experience, or a couple tens of 20 years, something like that. So yeah, don't hesitate to reach out if you want to give a talk. And we also keep a list of requested topics that we want to do in the future. So if you have experience with that, reach out so we can arrange something and give a talk for other people as well. Because today it's the first time that we're live streaming. Last time we did a small test and it went quite well, but today we're live. Not sure how to behave, but we'll see. So yeah, we're testing some things out. The meetups or the talks will be shared afterwards on YouTube as well. That gives people also a better platform to show that they're active in the community, and we want to be part of that as well. So again, thanks Asia Group for hosting. If you stay until the end of the evening, which I would recommend you do, we have a small raffle where you can join today for some goodies. I created a small app before the last meetup. There were some small hiccups. I tried to fix them yesterday, of course. So if you have some issues, come to me during the break, and we'll see. We'll figure out how it goes. So the format that we usually do it is having some lightning talks. So not everyone wants to start with giving a talk of 50 minutes or 40 minutes. So we give a platform to share something in 5 minutes and say, okay, I have some small things I want to share, but I don't have much time to prepare something. So that's why Lightning Talks is pretty nice. Yes.
Sorry to interrupt. Can you please show the QR code again?
Yes, yes, yes. It's also on the roller banner. Yeah. So I think we have 3 lightning speakers. I'm not sure if Gianni is here. Then we have 2 lightning talks today. So Frey will talk, and then Matthias will also do a lightning talk. So Frey, take the stage.
All right.
And then stop sharing.
Let's hope this works. This is live.
And then this one.
All right, let's see. Can I put this here?
Yeah.
Probably.
And then.
All right. Let's see. Again. You are sharing, it says, but I don't see anything there. Are we sure this is working as expected? Who is
Stop share maybe.
Okay, let's try again. TKNXLG. All right, awesome. So everyone can see this. I can see this. Perfect. Oh yeah.
It's mirror.
All right.
The mirroring install.
Yeah, display. Up. What? Alright. Here, this one has mirror built-in display. Awesome. Okay, that definitely took longer than the lightning talk. So today I just want to go over some options that we have with creating new projects in Flutter, because that's where we all start. And in general, there are 2 ways of doing this. You can either use a command line, or you can use your IDE's plugins in general. So I'm curious, who've created a new Flutter app once? I think basically everyone. Okay. Who uses the terminal command, Flutter create? I would say that's around 50%, something like that. For the other ones, who uses IntelliJ or Android Studio for that? And the other ones use VS Code, I assume. All right. I didn't like the VS Code one. It didn't give all the options as IntelliJ does. But I just want to talk about the fact that we can do a lot more with the terminal command as well. So, as a very recent study showed, 50% of Flutter developers actually use Flutter create. So I think it's important to know which options you can give that command as well. What I want to go through is like a general way of creating an app. It mostly starts like this, like, okay, we're starting a new project, so we run Flutter create my app, using the underscore there, because else we all get a mistake and get an error. And we're super happy. We open the project in your IDE. We remove 90% of main.dart of the Flutter of the counter app, because we don't need that. Then we maybe rename the directory because we don't want small letters and an underscore there. And then we remove the unnecessary platforms that we're not going to support anyway, because we just have a fixed set of them. And then we try to find all instances of com.example to replace that with our own. And we don't even bother removing the comments in pubspec.yaml. So does this seem familiar to any of you? There's somebody saying no. So OK. But the rest, I think this is people have gone through this process before. Now, I just want to say there's a few options that you can easily add on to the Flutter create command. And I just want to go over some of the general ones and show what is available. So here you can see a simple example showing the ones that I think you should try out. And the first thing that we have there on the first line is awesome app. This is actually not the name of your application. It's actually just the output directory. You can put any type of directory there. You can put it recursively. It will create the necessary folders for that. And the confusion with, we'll come to the confusion with the fact that this is not actually the app name. Another thing that you can define is the platforms. You can limit that, then you don't need to generate already a platform that you aren't supporting at that time. You can always add them later, but it's important if you add one later, you need to specify project name again if you use a specific option for that. Because if it's not filled in, it's going to focus on the directory name, which is where the confusion might come from. If you don't give a project name, it actually defaults to the directory name. And when using this option of project name, you can actually just have the Dart syntax with a snake case, but still have a different name of directory, and you don't need to rename it afterwards if you come across that. More importantly, try to always provide the org parameter. It's like in this example, com.skystone apps would replace the com.example. And for creating the identifiers such as a bundle ID or an application ID, it will just add the project name after that. Curiously enough, if you add another platform, you don't need to re-specify this. I don't know why. It kind of looks into the previous platforms, picks out the identifier there, and is able to reuse that. If you work in an organization and all your projects have to have a specific identifier, you can actually configure it in the IDE if you use that to create your apps, so it always takes that by default. And one more, and I think this is maybe the most useful one. Just add empty at the bottom. Avoid creating all those comments. Avoid creating the counter app and deleting it again. It will also it will not create any tests. But I think for basically everyone, the first thing you do is delete the test because the app that it's testing will no longer exist. And this only works if you use the template for apps, because you can use different templates as well. Here's some of the other options that you can use. You can also build for modules, plugins, and so on. There's a lot of different ones. Check them out. Check out what Flutter Create Help does. It shows all these options, and just play around with it. And maybe you can just, whenever you need to start like just a testing little project or any new project, you can just use some of these options as well. That's all. Ja. Nou, alsjeblieft.
Yeah. Okay. Hi everyone. I'm Matthias. Also work here as a Flutter developer at ACA Group. Today I'm going to give you a small lightning talk about custom render box. Try to keep it as short as possible, and my goal is to give you all a jump start if you haven't started or don't know anything about custom render boxes. Now, to explain custom render boxes, quickly show you this Flutter, the Flutter trees. We have our widget tree, element tree, and render tree. Widget tree is a thing we all know. It's what we use, where we define our containers, row, all our widgets. The element tree and the render tree is usually not used by us developers. Today, I'm going to explain you how we can create our own render objects, so in the third tree, for better development. So you're wondering probably why should I use custom render objects? Why should I even touch this third layer that Flutter normally handles all by itself? One reason is it's just impossible otherwise. You have very complex UI. You need to know the height or the direction, certain things that the widget tree just doesn't know, or it's very hard to get that information. Also for performance, sometimes you want to, for example, you need to hide, you can add a post framework callback, or you want to have a certain item and you use a stack with a padding. That padding never works, or you need to use a padding of 57 size, and if you're lucky it works on Android, whatever. So just go for performance and create your own render object. And the third biggest reason is for direct drawing when you want to draw complex items, complex widgets. For example, Hasselt button is much easier to create in a custom render box than using it on the widget tree. I'm going to show you quickly how you can create your own render objects, and you need to do two things, or create two things: your render object widgets, which will live in your widgets tree, and the render class, or the render object, that will live in the third tree, the render object tree. In my example, I'm going to create a gap, which I will use to create space between my items in a row or a column. Normally, you would use a size box, and a size box has a width or a height. But if you change your column to a row, you also need to modify your size box. In my widget, we'll just use one property, and in the render object, we will see what our parent is. And is it horizontal or vertical? We will put the space or the size you want on the correct place. Why do we need a render object for this? It is because we need to know the direction of our parent. It's much easier to have this data from inside our render object tree. And also it's a very good example to show people have no experience with custom render boxes. So I'll start with my widget, which is the class gap, and it will extend from a leaf render object widget. For now, you should only know that we have multiple objects where you can inherit from. In my example, we use a leaf render object. This will be different depending on how many children your widget has. In my case, I have no children, so it's just a leaf render object widget. And then I have my only property, the main axis extends, which is just the size. Like if you would in your size box, put your size, it's just the same property. Then the last two things I need in my widget is the create render object and the update render object. And here I will create my render object, or I will update my property inside my custom render object. Then we have my render gap, which is that lives in my third tree, which will extend from the render box, where I have the same property. My main axis extends, where I have a setter and a getter, and a perform layout. In my setter, I quickly verify the value. If it has been changed, I will modify it, and I will trigger a marks needs layout. This is important to let Flutter know he needs to redraw my UI, because as you know, the render tree is responsible for drawing the UI. And with marks needs layout, he knows I need to redraw something, and that will trigger the perform layout. And what does my perform layout? Here you will do your calculations or your checks for your custom render object. In my case, if it's horizontal, I will add it in the width, else I'll add my main axis extent to the height. So how do I use it, this custom widget? I just use it as any other widget, and it's just my constant gap. And here I have my column, a container, a gap, which is my custom widget, my row that also contains a container, a gap, and a container. And here the easy part is if I modify anything, which I mean if I change my column to a row or my row to a column, I don't need to modify my gap. The result is this, and something ugly. But if I would now modify my column to a row, without problems, my gap remains the same. If I would change my other row to a column, it changes, and I don't need to change my size box values. So for anyone who is interested in this and want to explore it on its own, I have 3 resources here. You can also find my presentation back online, and I will share it on the Flutter Slack channel. Okay, thanks for listening.
It's better. All right. Hello, my name is William, and I'm going to talk about code generation. So first, a little bit about me. I'm the Flutter lead and AI domain lead at iCaps. I've worked on apps like the COVID Save for Ampere, which is the delivery service of Volt.com, Cybos, which is a major financial conference, Blue Bike, etc., etc. And my 2 main passions two big passions are efficiency and animations. And if you've seen me before, I like shaders, and I sometimes talk about shaders. But not today. Today I'm going to talk about code generation. And there are three main types of generation that I'm going to talk about. The first, of course, as my AI domain lead role, I'm going to mention Copilot. It's the easiest. You just install it and it works. And you now have code generation. Awesome. But yeah, that's not interesting for today. File.write is the more basic approach. You can just write anything you want, and it will be literally written down in a file that you've specified, and then the famous build runner system. And I'm going to show you how it works a little bit, and then I'm going to dive a bit deeper as well on some more advanced thing you can do with build runner. So first, Copilot, yeah, you type something, it suggests something, you press tab, and you've generated code. So yeah, those usages is mainly for while you're writing, you're developing, and you can insert short to medium code, but you're not going to generate whole files. You're not going to generate all your models this way. So it's more for during development. So the first big one I'm going to talk about is file.write. File.write just writes code to files. I say code, it's a string, so you can write anything to any file. And you can input any string, and it will be written literally as you've declared it. So it gives you high control. You decide each character where it's going to be. But it's difficult, to make abstractions and to customize it a lot. And the bad thing is also you have no validation. So if you make a mistake in your string, you will write that mistake in every file that you generate. A small example. So on the left is the script that I've written. I just pick a file, result.tart, for example. I write my content in it, and I write it as a string. And then you see the result. So if I now forget a bracket on the left side, then it will also be forgotten on the right side, which is not that great. But it is easy to generate simple files or models or stuff like that. So the first package, I'm going to give examples for each approach. The first package that uses this approach is the model generator, started by Koen. It's used to generate models. So for example, if I jump into my editor, now if I need to open the README here, yes, all right. And I'm gonna show you our awesome template project. It's already in there. You'll see here a folder model generator. If you open it, it will contain a YAML file. And here you'll see some YAML code. So this is how we define our models. If your backend uses a Swagger, you can copy paste it and almost literally use that. You'll have to change a few properties. But yeah, if you insert this, it will generate files in your model folder. And in this case, the web service to do folder. So it will generate this file, which has the JSON key, which has the type, which has other properties. And it will also add some annotations, more on that later. But it will generate your to JSON and from JSON as well. So if the backend changes, for example, one field, you just replace it in your YAML, you run the command again, and then you've got your whole new working models. Another example, in the template project, our good friend just said you have to find all and replace all the com.example. That's an issue you have in our template project as well. So we automated it using scripts. And you'll see here a folder tool setup. And then you'll see some scripts. So those are written in Dart. And yeah, for example, the rename project, it will ask you what's going to be the name of the project, what's going to be the identifier, stuff like that. You just enter it in a command line, and it will just open those files and replace them in that file. So it's not smart. It just works on our template project, but it's easy to do simple stuff like that. And then one more example, also related to our template project, but this can be extended to any project. It's something I built recently, and it's called FGen. And I'm going to actually show you this one. So if I go into a new project, so this is a project which just has the main Dart file. I've now written a tool that generates files for you. So for example, I want to build a new screen. So I'm going to have to add a screen file. I'm going to have to add a view model file. In this case, I'm also going to add a repository, a web service, an abstraction of the web service. Those are 5 files. So I'm just going to generate them right now. Here you go. I've just generated those 5 files in the exact place. And if I, for example, go to my repository, I directly have a link already to my service. I have, in my view model, I will have a link to my repository. In my screen, it will be linked to my view model. So those files just been generated, and those all match each other. So this is how we do it in our template. I've made this a bit more abstract, and you can actually define your own templates. So for example, if I want to add a dialog, this is just a Dart file with some comments in it. And if you actually specify it in a YAML file, templates.yaml, inside your .fgen folder, it will read this template file and it will add it to the templates. So if I do fgen.help, it will already see here the dialog option. This is not something in the default tool. You can add your own templates, and it will actually add them as well to the help. This all uses just the file.write, and it's a bit abstract, but it also makes it a bit more difficult to work with. So the things I've just mentioned, using file.write, it's pretty easy. You can generate files that you can later then change. You can change existing files, for example, in a templates project with a script. You can generate files that don't need to regenerate every time. Think, for example, about models, translations. We also have a package that downloads our translations, puts them in files. It's also just a file.write. You don't want to do it every time you run your build runner. And then I've got a small demo as well. So for example, just to show you how easy it is, I've got an example file here. And it just does, it opens a file, file.dart, and it writes class example, static print hello world. So if I now run just the Dart command within the file, then it will execute that file, and it will generate a file.dart in the current folder, and it contains the exact same thing that I just said. But to show you that you can then also, how to easily edit files, it's just you find the file, you then read that file. Now you've got a string in your content, and that's just the string of the whole file. It's that easy. And then you can say replace everywhere where you see hello world and say hello Flutter Meetup. The same, you just run it with Dart, and now the file.dart contains hello Flutter Meetup. So it's very easy to work with, but very hard to make, very difficult, very abstract stuff. So in comes build runner. I think familiar to most people, I hope at least, that you use it. Build runner, it generates generate files. So it's not going to edit files for you, but it's going to generate new files. And it's going to use annotations to do so, most of the time. While you're working with build runner, you'll see that you receive a lot of details about the classes you're trying to you have annotations on. It will receive a lot of details about the code, and you're using classes. You'll use objects to generate the code. You're not gonna just input strings. You can, but it's bad practice. You can actually go pretty far with this. So the same example is all of a sudden a lot more difficult because it's very abstract. And then you'll see, yeah, you're always gonna return a library, and then you can start to do stuff with it. So this first thing you do is just the body of the file. You're gonna add a class to it. And a class is an object. So you're gonna instantiate the class object, and then you receive again a builder. And with that builder, you can, for example, say the name is the class name. Or in this case, yeah, it's gonna be example. And then you can add methods to the method. So you're not gonna say all of the methods are this, you're gonna say methods.add or .add all, and then you're gonna add your methods there. And then a method is another object, so you're gonna instantiate another method, a method object. And then again, you've got a builder, so you're gonna say the name is print hello world. It's gonna be a lambda, that just means tear off, so you've got your point. You're not gonna have the curly braces. And then you can set a body, which can just be anything you want, so you can do the whole thing again. You can add other stuff to it. Or you can just say, now I'm gonna finally write some code, and I'm gonna just insert it as a string. So in this case, print hello world. So what I didn't do here is I didn't add the semicolon at the end. It knows. I did have to add a static, so that's not correct, but yeah. The whole formatting is correct. I don't have to format anything, and you can do a lot of stuff with it. You can almost do everything. Sometimes you'll encounter some issues that you can't solve. Then you just want to enter the string. But then the issue is if you're starting with a string, you can't go back. So I can't say in this string, in the print hello world, oh, I want to add a class inside of this. That's not possible. Once you're in the string, you're at the end of the rope, and then the only thing you can do is add more string. So a package that uses this, JSON serializable. I just showed it 2 seconds ago, but let me show it again. So this is used in our template as well, in our models. So lib. All right. So what you do is you add an annotation. So an annotation is the add with some text to it behind it. So here the JSON serializable, you're just saying this object, this class, can be put into or out of JSON. And then you can add annotations to every field you want to change and specify other stuff, like, for example, the name of the JSON field. If you have to include it, if it's null, if it's required, stuff like that. Then at the bottom, you just add those two, and it will generate the todo.g file. And it will generate this for you. So it will generate a to-do from JSON method, and it will return a to-do object. Pretty basic, but yeah. How it actually works is more complex. So the class is just one side, the annotation is the whole other side, and I've just written a bit of code here. You don't have to go into it, but it's actually pretty magical code. What you can do is, find all annotations of a given annotation, all instances of that annotation. So for example, if I want to find every annotation from Flutter route, so everywhere where there is an @Flutter out, I just do this, and I receive in the code every class that has that annotation in this file. And you can just loop through every file and then just do something when you find this. So there's no actual searching for the literal annotation. No, you just use the annotation resolvers that's already provided for us. And then, yeah, you can peek at the values. So you've just set the name, for example, for the JSON key. You'll actually use peek and then the name to get the value that's in there. But you can go further if you've, for example, add an annotation to a class, then you can say, what's the constructor, what are the fields of this class, what are the arguments of the constructor of that class. And that's actually pretty useful information if you want to automate some things. So yeah, the class object, you can say the name, you can specify fields, you can specify methods, you can specify constructors, you can extend it, you can add mix-ins, you can do all those stuff just in with the class object. With the method object, yeah, you can enter a name, enter the lambda, you can return something, specify which type you will return, you can specify the body. For example, this is how you can call a function. So you just use a reference, write anything in there, and then call. And inside the call method, you can say what are the arguments you want to pass to the function. And then you have to convert it to code so you can pass it to the body. And for example, a field, yeah, the same way as before. You can, for example, add a modifier. This is how you say something is constant or a final or a variable. And then you can assign it to a value. And yeah, now I just did some string, but you can specify other stuff as well. And then the most important, well, something I forget, let's say it like that, is your build.yaml file. And in here, you're going to actually say to the build runner, hey, this is a build runner script that can be run. You're going to specify which function is going to be called. And you can specify, for example, I want to start with Dart files. I only interested in Dart files, and I'm going to generate a .navigator.dart file. You can then also say, I want to build it to the source, or I can also build it to cache, which is not actually code that you'll see, but it's cached somewhere in a build folder to be used for other builders. A small example, no, not yet. Some usages, yeah, so you'll generate files that never have to be updated manually. If you're gonna update them manually, then don't use build runner because they'll be overwritten. You're gonna extend existing code, or yeah, it's almost always based on existing stuff. So one time I did write build runner that will actually check a folder for assets and then generate a class with all my assets in it. That's possible, but most of the time you're gonna extend the code. And then, yeah, you're gonna generate files that have to update. So if it's just, yeah, generated once, for example, my models, you don't have to, every time you run build runner, you're not gonna update your models every time. So that's a bit annoying if you do that. And yeah, some examples are copy with, or to or from JSON, and stuff like that. So a small demo. Yes. Let's go to the build runner demo. So I've got a class, a package for my annotation. I've got a package for my generator, and I've got a project where I'm using the package. So this is something you'll very often see. two separate packages, one for the annotation and one for the generator. And the reason for this is in your pub spec, you can add dependencies and you can add dev dependencies. And the dev dependencies will be used in your build runner, but they won't be included inside of your application. So if you write a big generator and you just add the whole generator to your dependencies, then it will also be packaged, which is useless. So that's why you split it up. So the annotations is then added to the dependencies, and the generator itself is added to the dev dependencies. The annotations project is very, very small. You just have your class, your annotation that you're going to use. Most often you're going to actually add some documentation. I didn't do it for the demo, but yeah. That's the whole point of the annotation. And then in the generator, you'll actually see quite a lot of stuff. So I'm going to start with a build YAML file. You'll notice here that I'm referencing the builder.dart file. So I'm actually going to execute something in that file. Then I'm going to look for Dart files, and I'm going to generate a .cool.dart file. And I'm going to build it to the source. So then if I look into the builder.dart, you'll see the cool builder. So this is also referenced here in the builder factories. These are all the functions inside of that file that you're going to execute. And in here, I'm going to actually build a library with a cool annotation generator. And again, I'm going to specify that I'm going to make .cool.dart files. Inside of this generator, I'm going to look for my cool annotation. And then every time that I find the annotation, I'm going to execute this code, which will look for the message, which is my only property of the cool annotation. And then I'm going to generate it, and I'm going to format it, and then I'm going to emit it to the code, and then, some magic stuff that you just always copy-paste. And inside the library builder is actually how I'm going to do it. So here you'll see I'm going to build a library with one class called example. I'm going to print a message in a method. So that method is called print message. And then in that body of that print message, I will print the message. So all this set up. If we now go to the project, you'll notice that I've got my example.dart file with my cool annotation. And inside of that cool annotation, I have hello world. So if we now go to the project, so example project, I'm now inside the project, and I'm going to run Dart, the build runner. So it's the Dart run build runner build command. And they just changed the UI of it. I noticed today. And it's already done. So for a small project like this, it's very fast. For our project, it takes way too long, but yeah. Inside now my example.cool.dart file, I now have the class example with a method called print message, and inside of that print message, I say hello world. So if I now change a property here, so hello Flutter, and I run the build runner again, you'll now see that this file is first removed, then is re-added, and now it says hello Flutter. You can do pretty cool stuff, but I'm not going to be able to explain all of it today. It's a journey you'll have to endure. So now a bit more advanced. This has all been very nice, but for example, if I want to automate generating a navigator, I don't want 10,000 separate files for each of my screen. I want one file containing all of the methods to go to a screen. For example, dependency injection. If you want to create dependency injection, you want one file that contains all of your dependencies. You don't want for every dependency a separate file. So that's going to be a bit more difficult. And in here, a slide I made a few weeks ago, a few meetups ago. But this is how you'll do it. You've got your code. You add annotations on that code. And you have one builder running on that code that creates JSON. That JSON file is not included in your code. It's actually put in your cache, as I mentioned before. And so you don't notice that it's actually converting your code to JSON files. And then another builder is going to combine all those JSON files, and it's going to generate one single file or 2 or 3 files, depending on how many of your other annotations you use. So for example, I've got my Flutter Navigator annotation. So this is from the second builder. And I've got the Flutter route. It's for my first builder. And I've got that Flutter route in many different files. Then you can just, you're going to use the Flutter route to extract the most important information. You're going to put that in a JSON file. And then in the Flutter Navigator annotation, I will gather all of those JSON files, and I'm going to use those to create one big file with all of that data in it. So yeah, just a small example. Then you can have, for example, go to second page and show dialog example in a single file. The things I've just said are available in the Flutter navigation generator. So we now automate everything of navigation as well. So if we add a new screen, we just run it, build runner, and now our generator has a go to that screen method with all of the arguments in the constructor parameterized, so you don't make mistakes. If somebody changes the argument, runs build runner again, then it's updated, and you'll notice where in your code you use that wrong, and you get errors. So that's pretty nice. Let me open it up. I can go read and yeah, here you'll notice I've got an annotations and a generator. If I go into the generator, into the example, I can show you the output of it. So I've got a main.tart file which contains a lot of screens. I just add the Flutter route annotation. You can add it multiple times on one widget. You can add a Flutter dialog annotation or a bottom sheet. Yeah, for example, here the Flutter dialog. Then we have an example which contains a Flutter Navigator annotation. And then it results in this file, which is my actual navigator, which contains all the code for the navigator. It contains a function on generate route, which you can just plug into your material widget. And then it has methods for every page you want to go to, for example, the go to second page, which then has return types correctly. For example, on my home page, I have a string, which is a title, but it's nullable, so it knows it here, and it's not going to make it required. If it was not nullable, then it's going to make it required, stuff like that. And yeah, if you're interested in how it works, it's going to contain a lot of builders, a lot of generators. So one generator for each type. So this is the Flutter route. So it's the @Flutter route annotation that's going to be used here. And in the Flutter Navigator generator, we're going to use the Flutter Navigator annotation. And then it's pretty extensive. I'm going to need a few talks to get through all of this. But yeah, if you're interested, it's all online. Feel free to look into it. And I didn't find this out myself. I just stole copy-pasted a lot of injectable code. So injectable is to generate your dependency injection, which was pretty helpful to get started. So you're going to put it in a JSON. I mentioned this. And a big part of the injectable is how to resolve types, because that's a big part of it is, if I've got an argument and it's a model that I use somewhere else in my project that I've defined in another file, then that file is going to be imported into the resulting file, and it might be that it's from a package. It's pretty difficult to know where your models is from, so that's using a type resolver and just copy paste it. I did the same. And then in the build.yaml you'll define two builders and the JSON builder. So here I'm gonna use Dart files and put them into navigator.json files, and I'm gonna build them to the cache, so not to the source. The user isn't gonna notice it. And then it's important if you've got multiple builders that you run one before the other, so you have to specify runs before and then your other builder. And this is to generate a single file from multiple files. It's going to automate big tasks. For example, your dependency injection, your navigation. We're also working on the widget book, that you can just add an annotation on a widget and then it's going to be added automatically in your widget book, and other stuff. For example, Drift also uses some of those stuff. Those are a few of different types of generation. It's more an intro today. I'm not going to be able to dive deep into those types, but if you're interested, do hit me up. I can talk a bit longer than this, or I can point you in a direction where you can find more. Some links. Most importantly, this presentation, it's a Flutter deck, so you can just run it at home, and the demos is also in the presentation, so you can run everything on your speed. And that's it. Any questions? Yes?
Can we apply certain formatting rules to code generation with build runner? For example, if you say like I want 120 characters per line instead of 80?
I don't know, and mainly because it doesn't matter. It's a generated file. You're not gonna really change anything in it. If you want to read the file, just format it. I mean, it's just, and you formatted the file, so.
So it's not like if you would use the library generator to generate a starting point and then continue from there?
No, you're not gonna, if you change files that's been generated by build runner and you run build runner again, the file's gonna be overwritten. So don't do it, it's a mess. I did it at the start of my career a few times. And then you see all your hard work disappear because your colleague runs a command. Not happy times. No, but if I quickly jump into something that is generated. So the cool file, this now is already pretty good formatted. You might be able to. So in the generator, it's gonna format it here. So I don't know if the Dart formatter has special properties or.
I think that uses the analyzer package.
Yeah.
And that will just be using the default config. So it's not looking at your analysis options. But I think it's important just to add the generated files to your more section in the analysis options.
Yes.
Because it's generated code, it doesn't matter that it's not formatted well, just should compile. And I think it's important that you take into account strict modes. Because if you create a package that doesn't generate code that uses strict modes, then it cannot be used in projects that use
special option in your analysis options that, yeah, there's more strictly typed shipping. So I think that's one important part that you need to take into account.
Yes.
Because it can work for your project, but if another project uses strict mode, then it would not work.
All right.
Maybe one more. Maybe I should have checked this before I did the lightning talk, but how does Flutter create, generates its projects from?
Good question. I have no idea.
It's a mess.
Okay. It's a mess. Yes.
So I have a question. So me personally, I never used code generators. So I'm asking myself, did they really miss something, or where I could apply this to really give me a big added value? Can you give us an example where we believe that in the long term this is something that is worth investing to set it up?
Yeah, so one area that's definitely helped us is the navigator, both the navigator and dependency injection. So dependency injection is an easy one. You don't have to think about any of the dependencies. You just add the annotation, and then it will figure out which have to be instantiated, which have to be created first, and it will do it in the correct order. And then if you've got a circular dependency, it will actually tell you, hey, I can't generate anything because this is a circular dependency. The navigation side, previously we written our own navigator, and it took quite a while. And now it's just generated. If I use the auto generator and the fgen, I can create a new screen in 2 commands, and I have the method already ready to go to that screen. So it used to take 3 story points to create a screen. Now it's just the one.
So it mostly fit like a big project where you're constantly adding new screens and new models, and you wouldn't recommend this for a small project?
It depends, yeah. Indeed, if it's just a very small proof of concept, then you don't need to generate anything. But the bigger the project gets, the more I would suggest generating code, because it's already validated. I've written tests for my generator, so I know that works. So if there's an issue, then it's probably me.
Okay.
The more you do yourself, the more you can do wrong.
So they remove mistakes and adds additional automation.
Yeah.
I think a good starting point, if you haven't used a code generator before, would be JSON serializable.
Yeah.
It's just to convert your data objects to JSON to send it over the network. You just define your class, and the JSON serializable, it handles everything to convert it to like proper JSON format, and that's a really useful one that is
Yeah.
really popular as well.
I've got it in the project as well. So you just add this annotation, add JSON serializable, and then if you run build runner, first have to find it, JSON serializable there. It will actually create a second file, example.g.dart, which contains all of your properties, and it will put it in JSON. So it's not something that's hard, because I can just use my editor and create JSON serialization like this, and now I've got the same thing. But the difference is, if I now add a property, I'm going to forget to recreate this. And if I just use build runner, it's going to automatically create it if I run build runner again. And a big part, if you're working with multiple people and you're both adding stuff to the class, then you're going to get merge conflicts, and merge conflicts resolving is much easier if you just have to run build runner.
All right, thank you. I think the JSON serializable also really helps with checking if certain or required fields are there or not.
Yeah.
So for example, if you receive an object from backend and it doesn't contain the required key, and it will throw an error, this key is missing. And now that's all generated for every class automatically, and otherwise you have to write it yourself for each class. if you're doing multiple projects, for example, then yeah, just having a good structure over your different projects is even better. And then generate means do it go ahead.
Yes.
Do you often use Mason as well, or?
No. I'm not a big fan of Mason because I didn't write it. No, because it generates whole files and the fgen is also future-proof of creating parts of a file. But more importantly, the fgen, it depends what you're creating. So if I'm just creating a screen, I don't need the provider widget. If I'm creating a screen and a view model, then I want to add the provider widget already with the import of the view model automatically.
Yeah, but yeah, that you can also do in Mason with configuration.
Yeah, that's possible. I don't know. When I looked into Mason, it wasn't possible, or I didn't find it easily. And this is what I use. This is what I create.
It looks quite nice. So
Thank you. Yeah. Perfect.
Right, I think there are probably a lot more questions. But I will take a break for how long? 15 minutes? 15, right?
15.
Yeah, 15 minutes. So ask your questions to William during the break. And then we'll go with the next talk. We give shiny stickers to each speaker to promote speaking. So if you want to have a sticker yourself, take the stage next time.
Thank you.
Next main talk. So Stan will be talking about mobile sensors. Yeah. I think that's a topic that we've not yet seen. So that's good. Yeah.
Okay.
Take the stage.
Yeah. Hi everyone, I'm Stan. I work at the ACA group. And my talk will be about how to detect the arrival of trains at the platform and their departure using accelerometer data, but the focus will be more about the process instead of the final solution, on how did we get to that point. The journey starts with our customer, SNCB, who had an issue with that they only have approximate data about when their trains arrive at platforms, when have they departed. They don't have any statistical data from that because they get that data from Infrabel and they don't deliver very good quality of data. So they came to us. We were developing the mobile application for the departure procedure. Hey, can you help us with that and investigate that? To tackle this problem, the main process was actually using the scientific method. It's just actually fancy name for 6 simple steps on how do you systematically tackle a problem to try and get to your solution the fastest. The first step is just, what is my problem? Identify it. The second step is analyze the problem, look what known truths do we have, what things are we looking at, what properties does our problem have. You form a hypothesis, what solution are we going to try and what solution are we going to try to solve our problem. You test the hypothesis later on, so you perform an experiment. And out of that experiment comes data. So you analyze that data. And with that data, you can form conclusions. It's as simple as that. If you're lucky, in the first pass, you get to your solution. If you're unlucky, like most of the time, if it becomes more complex, you'll need to do a few iterations of this. So their question, we only have approximate data, please fix this. Isn't something we really can work with. So we had a little bit of talk with them. What's the actual problem? What do you need? And we came to the question, is it possible to detect the arrival and departure of a train at the platform with a good time resolution? Because they actually want to know it within a few seconds and not like it has been here for like 5 minutes ago or something like that. And the limitation is using a smartphone because we were developing the mobile application. We can, of course, enrich it with other info, but that was our main goal. Then you have your second step, the problem analysis. Can we measure our problem? Can we quantify it? What data do we need? What properties do we have? What known truths do we have? Do we have experience with GPS? Do we have experience with sensor data? Do we have experience with a few things that can help us solve the problem? And in this case, it's just what factors do play a role for our research question. And it is looking at the properties. So we're looking at arrival and departure at a platform. What does it actually mean? It's arrival at a platform is your position becomes at the platform. So you have a location, a GPS coordinate at your platform. The velocity becomes 0, your train comes to a standstill. The departure is you're no longer at the platform and your velocity is no longer 0 because your train is leaving. So we know what we're looking at, and then what things can we use for that? What capabilities does our smartphone have? Basic things. We have GPS, contains coordinates, it contains velocity, so we might be able to do some things with that. So we try to form a hypothesis. It's just an educated prediction. What are we going to try to do? What is our proposed solution? But the important part is we should be able to prove or disprove our hypothesis, because if we cannot do that, we can't form a conclusion, so we do not know if we have solved our problem. It should be measurable, just because you need to prove it. It should be objective, so that you do not bias your hypothesis towards your answer, and specific, because you need to be able to test it. So the hypothesis we formed based on our analysis is that if we just collect the position and velocity using GPS, we can reliably determine our arrival at the platform. Then the next step is, okay, we need to test our hypothesis. Can we prove that it really works? So we design an experiment. We confirm or, in the end, want to confirm or reject our hypothesis. But as I said before, it requires measurable results. So they should be fair and objective. You need to take into account that often if you try to prove your hypothesis, you're going to bias your results because you're trying to look for the answer. But actually, it's often more opportune to try and disproving your hypothesis. Find the edge cases where it doesn't work. Maybe it's okay if it doesn't work for those edge cases, but try and look for them. Just make sure that if you test things, that your data represents the reality and focus only on the things you want to test. Forget about everything on the side. You're looking at your hypothesis, the thing you truly want to prove. So in this case, we designed an experiment. Was how do we detect that you're present at the platform? As I said before, you have your location at the platform. We used things like bounding boxes. If you enter the bounding box, you're at the platform. If you leave the bounding box, you're outside of the platform. Around the stations, you see two bounding boxes. That is just a Schmidt trigger, which ensures some stability in if you enter or leave your region to prevent a lot of fluctuations. Then, as we were only developing an Android application, we just used a fused location provider from Android, just because it already gives us out of the box some very good combination of GPS, Wi-Fi, and everything like that. So we get the good enough location data. Because we did, before this question, we already did a proof of concept for them. We knew we had some problems with having GPS on a train because you're in a Faraday cage, you get reflection, you don't have GPS signal. Signal might be spotty. So we introduced a few extra tools to help us. The things we tried were a Kalman filter, a route mapping or route snapping filter, and a train model filter. I'll, in short, explain what those were. The Kalman filter we introduced because we have some GPS drift and we have especially some GPS jumps that you are jumping around on your track. So the Kalman filter, we combined measurements over time of two different sources. You have your fused location provider, but you also have accelerometer data together with a rotation vector, where in the first step, so originally we had a location, then you get accelerometer data and you're going to use that to predict where am I going to be, but we do not use that point yet. We start using the point on the next time we get a location update. Then at that time, we're going to combine our predicted results with the one we got from the fused location provider. And then based on how sure we are of each value, we have a weighted average just to stabilize our GPS. That had some very good results. The second part is a route snapping filter. We have the advantage, we have a train, so we know we're on the track. So we just take our coordinate and say it's on the route, the nearest point on the route. And this fixes some signal reflection we have from buildings that sometimes are a kilometer away, and we get it consistently next to the track. So it helped us a lot to detect the stations. And the last part is the train model filter. It's just actually trying to have a representation of the physical limits of our train. How fast can it go? What's the turn radius? What's the maximum speed it can go through a corner? This actually made our results worse instead of better, so we threw that out in the end. But those are the things we used within our experiment. Then, of course, we're going to analyze the data. And during the analysis, it's did we prove our hypothesis? Are there any remaining issues? What new insights do we have? Have we learned some things? Do we need to tackle some new problems that arose? Also important, communicate your results. So document what you see, document how you interpreted them, because in 3 years you will no longer know what you did, or the next developer especially doesn't know what you did. And also at that time you can assess the likelihood that going further with your solution or the path you're going through will deliver a result, or it totally doesn't. In this case, I wrote the application, did some tests, came to the conclusion what the best combination of filters was, and the results we had here were very good. We can detect our station arrival. It was very stable. We used the combination, as said before. The Schmidt trigger ensures stability, except there are some remaining issues. Because in our original research question, it was important that we had a very good time resolution, because we want to know that we're at the platform. And sometimes you don't get any GPS data until the train guard leaves the train and then possibly hits up a GPS satellite, and then suddenly it works. The velocity, where we depended on, was totally unreliable. I had times I had it constantly, I had times I didn't have it for hours. So I couldn't use the velocity from our fuse location provider, because it depends on what the source is the data comes from. So yeah, that's an issue. So it's back to the drawing board. We're gonna go again through the cycle. And the identification of the problem here is what were the issues from our remaining issues from the previous part, that we just are missing a good time resolution. So we need to analyze our problem again and look how we can continue further. At that time, we had a master student at our company who was doing some basic machine learning using a naive Bayes classifier, which is just a probabilistic model to determine, to predict what the outcome is. And he had some good results with using accelerometer data to determine if you're on foot, by bike, by car. He had a 96% accuracy. We have a high frequency, good time resolution. So for us, it looked like a viable path to go through. We previously defined the being at the platform based on the coordinates or based on having zero velocity. But now it's more the idea of your train guard is walking around on the platform, and in the train is still walking around, but you also have your train that's in motion. So we might be able to start looking at the acceleration of the device he's holding to determine if he's there. So this translates to a walking acceleration pattern and a superposition of walking and the train in motion. So our hypothesis was, if we use a naive Bayes classifier, we can differentiate between walking and its superposition with a train in motion. So it's time to test this hypothesis that we can really use it. And that of course starts with training the model. I did build a basic mobile application to gather the data, where I could also classify it. Hey, we're driving. Hey, we're at the platform. It's easy as that. I did the analysis just in Python. I looked at, so the naive Bayes classifier uses different properties of your data you can use to predict your results. So I tried a lot of them. I also included GPS in the end, the velocity calculation on how far are we from the station. But the results weren't very good. We're really lacking accuracy. What you see here on the right is the confusion matrix. You have the true label on the left, at the bottom the predicted label. While driving, we can detect that very well. We have 94% accuracy, except when you're at the platform. Half the time it says you're at the platform, and half the times it says you're still driving. So we can't do anything with that. I did some box plots of the data we had of the different features. There was just too much overlap. So it was the model itself was too simple to try and find the patterns that are in our accelerometer data. Also, just based on the data we looked at and some further thinking and everything like that, we're missing the changing of the velocity, going to zero, changing the velocity, starting from zero again, moving away from the platform. So it's missing the transient nature of it, of all those things. So we were trying to go and look at that info. So probabilistic models miss the transient nature of arrival and departure. And so our problem analysis is we got from our previous 2 cycles, we had our probabilistic models like the naive Bayes classifier. Cannot differentiate between the patterns, and the velocity and the position alone aren't good as well, because we're missing time resolution. But because I was busy with also looking at what data do we have, I started getting some ideas that I might just be able to do some basic signal processing of our data, and we'll see in the end where we're going to get, if I find something different, where we can do this. So the transient nature is just the deceleration followed by a period of no acceleration, and the departure is acceleration preceded by a period of no acceleration. So we might want to start looking if we can find that back in our data. And our hypothesis here was that we can form an algorithm which allows us to do something with it. We didn't have an exact idea yet because it was completely new terrain for us. But we had the idea that because we were using accelerometer data, we have good time resolution, we're expecting that we find the patterns back. So we try and form an experiment, or at the meantime design your algorithm to detect the arrival and departure. Here in the experiment, I just used the data I gathered before. I'm lazy, I'm not going to do that again. And I'm just going to start also just in Python, try and do some signal processing and see if we can improve on the data. And we'll go through 8 simple steps in the next slide, in the next 8 to 9 slides, to see how we got to the final result. Maybe first, what you see here, the green parts are we're driving, the red parts are we're stopped. So red part, we're at the platform, green, we're driving. On the y-axis, you have the magnitude, so how big is our acceleration. On the x-axis, it's what sample count was this, what is the index. So it's similar to time, just without how big our time resolution is. If we look at this data, I see a curve with a lot of fluctuations, but there wasn't really anything we could do with it yet. But because we knew we were looking at something similar to velocity, it was actually just the idea, let's sum it up and see. It approximates something that feels like velocity, so let's just sum it up and see what happens. And then you get a curve that looks like this. Okay, the velocity doesn't become 0 or constant in our stopped regions, it keeps going down. But if you look closer at the data, I hope it's visible, is you see changes in the curvature of your slope. So your slope goes down, then it drops, and then it goes down again with a constant value. And here, especially on arrival, it goes down a lot when you arrive, and then it becomes less steep. So the slope of your curvature, you're looking at that. So mathematically speaking, it's just the gradient. So we can try and represent it by taking the gradient. But if we do that with our data, what you see here is the red values are the original data, and the blue values are the gradient. So we get our original data back, which is because we have micro changes in our data. We have a lot of noise in there, so it's not unlogical that we are not seeing anything here. But we can just smooth out our data by taking a moving average. Just take 1 second of data and average everything out, so it's your change in acceleration becomes a lot smoother. And if you then take the gradient, you get something better. You have here you have the 3 channels in your accelerometer data. You have the X, Y, and Z channel, just the axes, and we didn't care about the orientation at that point. But you can start seeing that especially for the red curve, it's centered around 0. In the stopped region, we do not see a lot of acceleration there in the gradient. The blue one isn't centered around 0, but that's because we had a constant slope, so that's the drift in our velocity. In the green one, we have some periodic data, probably some electronic noise or something that's in there. We're detecting some things that aren't really acceleration. But we would like to have them all centered around 0. I would like to have the large period ones removed. So I just introduced a high-pass filter that's just filtering out everything with a very large period. They are just thrown out. And now everything is, when you're stopped, everything is centered around 0. They're a lot smaller than when you're driving. You have a lot more fluctuations when you're driving, and you see that coming back all the time. As I said before, I don't care about orientation, so I'm just going to take the absolute value and sum up everything and just want to work with the total acceleration we have at the time. And then you have a curve that looks like this. So again, it becomes even more noticeable that they're a lot smaller when you're stopped. So now it becomes quite easy. Just take a cutoff, throw everything that's a lower value at some point, throw it out. And then now I can really tell my program what it needs to do. I have a period, arrival was deceleration followed by a period of no acceleration. Departure is having no acceleration and a period of acceleration, and that's what we see here. You just look, do I have data at this point? Yes. Okay, look in the future. Do I have for a period of, say, 30 seconds, because we know how long a departure procedure takes, do we have a period of 30 seconds where there's no acceleration? Yes, okay, then we're arrived. The same again at the end. If you're departing, you have data, look before it. We have a period of 30 seconds with no acceleration. Okay, we have departed. Then you get, this is the data that comes out of that simple calculation. +1 is departure, -1 is arrival. You have some false positives, which isn't terrible. We can work with that. We have other data. False negatives would be worse because we cannot generate data, which we do not have, but we can throw data away based on analysis, based on a GPS, for example. We can throw this out. So we have no direct dependency on GPS. Maybe for cleaning up our data we have, but so we're not, our time resolution becomes good because we take data that uses sensor data that's has a very high frequency. So we have good time resolution. We had no false negatives in all the data I tested. False positives we can remove, so that's good. The analysis can be done on device. We're not using it to detect the arrival for the departure procedure. We are using it for statistical data afterwards. So it doesn't matter that we have to wait 30 seconds for that. And we just need a few basic signal processing tools to detect the arrival. So our conclusion is it is possible to do it. But the thing I hope you take the most from this presentation is just follow a few simple steps where you identify your problem, analyze it, form a theory, test that theory, analyze it, conclude on it. That you can do that for big steps, but you can also do it for smaller problems if you're debugging. You don't have to write everything down, but it's a mindset you can use to get to the end, in the end, to your solution. That's it. Thank you for your
Because we're talking about the drift, did you also test it on other devices and see the same resolution?
No, because in the end, we didn't implement it in production. They had a question, and 3 weeks later they decided to. Actually, we do not need that info, so they still don't know where the trains are at what time.
Okay.
That's how surprising. So they didn't. We didn't continue with the project. So I think I did test it with 2 devices, but it was. But actually, it was less of a problem because they only have one type of device. So it could be that between different between the same type of device but different devices, it could still be. But I haven't tested it.
Okay.
Yeah, maybe a silly question, but we are still talking about trains, and Koen and myself spent a wonderful hour and a half stuck on a train on Friday. Do you have like false data with delays, where it says like, you're at a stop, but it's just the train that's stopped and it's at a delay? Do you then still need GPS to rectify that, or?
Wait, what? I didn't get the
So
question.
did you get false positives for the train is now stopped, you are at a platform while it's just
No,
stopped somewhere and delayed?
the false positives is just because your train is accelerating and it feels constant acceleration feels a bit the same as no acceleration. So it's no change in acceleration type. But that would be one of the problems if it stops right before the platform because there's another train before that. That might create some issues with your data. So that could be there.
Thank you. Well, first of all, very nice presentation, Stijn. It was really interesting. You mentioned that you only had to build an app for Android, right?
Yeah, because the NMS only needed an app for Android.
So my question is, now that you have experience with Flutter, do you believe that for a project like this, which is not a typical Flutter project, we can say, do you think that Flutter can actually be a good choice for something like that, where we need a lot of data from the hardware? Or you think that you have to go native in such projects?
I don't think you have to go native there. If you would use the platform channels there, it might not be a good idea to send too much data over it. I haven't tested it. But you could do the analysis on the native side if you want.
Okay.
You just, because we're reading out, it's the sensor data you'll get from the native APIs. So I don't know how good the bindings are for that to Flutter, but you could just do it purely native, and then the end result you send it through.
All right, thank you.
No problem.